Okay, so today we're going to be talking about writing a linear equation in the form y equals mx. So that is our objective. I can write an equation of a line in the form y equals mx. Okay, so now my learner's question is going to be very similar to my objective, but I'm going to say, how can I use information from a graph or description to write an equation in the form y equals mx. And I know that's kind of long, but it's going to be important that we have the graph and description parts. Okay. So, reminder, in the equation y equals mx, m equals the slope or the unit rate. Okay, it means the same thing. Okay. In this specific equation, y equals mx, the y-intercept is 0. Okay, so remember, sometimes we have y equals mx plus b, and b is my y-intercept. Okay. Because the line goes through the origin. And remember, that's a proportional relationship. Okay, so when we have a proportional relationship, we could write it y equals mx plus 0. But that's silly because we know adding 0 doesn't actually do anything, so I'm not going to even write that. So it's just y equals mx. Okay, so the b is technically 0. Okay, technically the y-intercept of my equation is 0, but I don't need to write it. Okay. So example number 1 says, what is the unit rate slash slope of this line? Okay, and we're going to make sure we label. Okay, because I have labels on my axes, I can label. Okay, so remember, a unit rate is the change in y for one change in x. Okay, so if I look here, okay, here's my 1, okay, I went from 0 to 1, and my y went from 0 to 30. Okay, that's my rise over run, 30 over 1. So my unit rate is 30, and 30 represents miles, so 30 miles per 1 hour, or per hour. Okay, so that's the unit rate. Okay, so now it wants me to write an equation of the line in the form d equals rt. Okay, d just means distance. I'm going to label all these points here. Okay. R stands for rate, or that unit rate, or that slope. And then T, hopefully you guessed, is time. Okay, so this is like my Y, the rate is like my M, and T is like my X. Okay, so it's still Y equals MX, it's just they're using different letters to represent the actual pieces over here. Okay, so I have D equals, my rate is 30. I'm not going to put the labels in, okay? You don't want those labels in, it just gets confusing. And then T. Okay, so there's my equation. So my rate became my slope in my equation. Okay? Okay, C. How far will the car travel in 2 hours? What about 10 hours? Okay, so they're asking us to think how far will the car travel? Well, let's look and see if our graph can tell us. Okay, in 2 hours, we have that on our graph. That's 60 miles. Okay, so we know it's going to travel 60 miles in 2 hours. Okay, now, is 10 hours on my graph? No, it's not. Okay, so I'm going to use this formula, this equation, d equals 30t, to find out. Okay, well, 10 hours, is that distance or time? It's time. So that 10 is going to go in for t. So I have d equals 30 times 10. And then my distance becomes 30 times 10, which is 300 miles. Okay. So for 10 hours, it's 300 miles. Okay. Now, we're going to kind of go backwards. So how long will it take the car to travel 120 miles? What about 510 miles? Okay, let's see if 120 is on there. Okay, and that looks like 4 hours. Okay. What about 510? up 150, but not 510. So I'm going to have to use my formula. So D equals 30t. Well, now is miles distance or time? Miles is distance. So I'm plugging in 510 in for D. And then I need to solve for t. So to solve for t, so remember how I said solving equations comes back forever? Well, this is part of that. Okay, so I'm going to divide by 30 on both sides. And t equals, if you divide that out, 510 divided by 30, you get 17. So it takes 17 hours to drive 510 miles. Okay? Okay, go ahead and do the you try number. That's supposed to be you try number 1. I'm sorry. You try number 1 on the back. Okay, so a linear equation, the definition of a linear equation is an equation that makes a straight line when graphed. Okay, and so we have two forms. We have y equals mx, which is what we've been talking about so far in this lesson, and y equals mx plus b, which we'll get to at a later lesson. Okay, so this is now. Okay, this is what we're talking about now, and this is what we'll be talking about later. Okay, so example number 2, it says a restaurant is running a lunch special where all prices are 1/3 off. Write an equation that models the lunch price y based on the original price x. What would the lunch special price be for a meal that is usually $6.99? Okay, so we have our original price, okay, x, and we are taking off 1/3 of that. So taking off, okay, off would be subtraction. Okay, so we're taking 1/3 off, okay, but it's 1/3 of my original price. So my original price is x. Okay, and we know that's equal to the special lunch price. Okay, well, if I have 1x and I take away 1/3 x, okay, you can think of 1x as 3/3 x. Okay, because 3 divided by 3 is 1. So if I have 3/3 and I take away 1/3, okay, that leaves me with, and I'm going to go ahead and put my y on the left side just because that's that math convention that I like to use. Okay, 3/3 minus 1/3 just gives me 2/3 x. So there's my equation that represents what happens when I take 1/3 off of that lunch price. Okay, there are still 2/3 left. Okay, now it says, what would the lunch special price be for a meal that is usually $6.99? So I have to decide, is that my y or is that my x? Okay, well, it says usually $6.99, and we're looking for the lunch price. So we're looking for y, so we want to solve for y. So that means I'm going to plug $6.99 in for x. So I have y equals 2/3 times $6.99. Okay, so if I plug in 2/3 times $6.99, I get $4.66. Okay, so it would cost $4.66 for that lunch special. Okay, okay, go ahead and do the real you try number 2. Okay, example number 3. You burn 500 calories when you work out for 25 minutes. Write a linear equation to represent this situation. Okay, remember when we write a y equals mx equation, okay, we need this slope or this unit rate. Okay, so I'm going to need to find the amount of calories I burn for 1 minute. Okay, 1 minute, one only. Okay, so I know I'm looking for calories per minute. Okay, so I'm going to have to divide 500 by 25. So 500 divided by 25, I get 20. Okay, assuming you burn the same amount each minute. Okay, so that's going to be my unit rate. So now I'm just going to take that and plug it into m. So y equals 20x, just like that. Okay. Okay, go ahead and do the you try number 3.